Hey everybody, welcome to today's lesson. For today we're going to be covering Pythagorean theorem. So first thing I want to mention is at the top there is this link to a website that'll go further into the theorem. Unfortunately on the school device that I have I'm not able to open up the link for you, but I'll be posting it in the Teams page. So if you'd like to look further into this, you can as well. Now, for Pythagorean theorem, everybody's probably heard about a squared plus b squared equals c squared. Now, we're really going to look at what that means and dive further into it using kind of the rules that we've learned so far about squaring and also finding the roots. Now, in every right triangle, the sum of the squares of the two shorter sides, so a and b, is equal to the square of the largest side, which is c. Now this means that if we have one that is 1, 2, 3, 4 by 4, it's going to add up to 16. We have 1, 2, 3 by 3, it's going to add up to 9. So 16 plus 9 will be equal to this one, which is 1, 2, 3, 4, 5 by 5, which makes 25. So this stays true to the theorem. Now, if we know any two sides, we can always find the third. In this situation here, we don't know the hypotenuse, which we call C in this situation. Now I'm going to label this A and this side B so that we can solve for C. Now going by A squared plus B squared equals C squared, we can fill in what we know. So A we have as 15 squared plus B, which is 20 squared, equals C squared. Going back to our first page in this booklet, you can use as a reference, but remember we do need to memorize these squares and square roots. Now 15 squared gets us 225 plus 20 squared gets us 400 equals to C squared. 225 plus 400 gets us 625 equal to C squared. Now, in order to get the square off of the C, we must find the root of 625. Now, 625 is a perfect square because it turns out to be 25. So 25 equals C. So our hypotenuse, the side that we don't know, would be equal to 25. Going on to the next page, I want to again label the sides that I'm looking for. So I have A, B, and C. So I'm going to set up my equation, which is A squared plus B squared equals C squared. A we have as 12 squared plus B we have as 7 squared equals C squared. 12 squared gets me 144 plus 7 squared gets me 49 is equal to C squared. For 144 plus 49 gets me 193 is equal to C squared. And in order to get the square off of the C, I must find the root of 193. Now, if we flip back to that front page, we're going to find that there is no perfect square for 193. But the thing that we do know is that 196 is a perfect square. So we know it will be close to 14, which is 196. Now, if we did put this into our calculator, we're going to find that C would be equal to 13.89, which stays true. So we're close to that 14. And whenever we don't have that perfect square and we are asked to do this on a non-calculator portion, we'd just be looking at what we're closest to. But if we did have this for the calculator portion, you would just complete the question and find that we're looking for 13.89 for C. For the third example here, I'm going to start by labeling again. Now I'm going to label A, B, and C. Set up my equation of a squared plus b squared equals c squared. A we don't know, so I'm just going to leave as a squared, plus b squared is 9 squared is equal to 15 squared. A squared follows, plus 9 squared, which is 81, is equal to 15 squared, which is 225. Now, in order to move the 81 to the other side, we have to do the opposite. The opposite of addition is subtraction. So we're subtracting 81 from both sides, which removes it from the left and moves it over to the right. Meaning a squared is equal to 225 subtract 81, which is 144. To get the square off of a, we must find the root of 144. So a is equal to 12 because it is one of our perfect squares. For C, we have our unknown at the top here, which is going to be a. Then we're going to label that B and label that C. Remember, the important thing is we're always labeling the hypotenuse C. It doesn't matter which side is A and B. They could be flipped, but the only thing that matters when we're setting this up is that C is always our hypotenuse. So A squared plus B squared equals C squared. A squared is our unknown, plus B squared, which is 16, equal to C, which is 23 squared. Again, a squared comes down, plus 16 squared, which is 256, is equal to 23 squared, which is 529. In order to move the 256 to the opposite side, we have to do the opposite. So subtract and subtract by 256, giving us a squared is equal to 529. Subtract 256, which gives us 273. Now, to get the square off of 273, we have to do our square root, and we'll find that there is no perfect square for 273. What we want to find is what's going to be closest to it. Now, it's going to fall in between two different squares, or perfect squares, so I'm going to write down both of them. I would have root 256 is equal to 16, and root 289 is equal to 17. If I think about where 273 falls in between 256 and 289, it's fairly close to the middle of this. So I could guess that it's probably around 16.5. So it's close to the middle, so that would be a good assumption. If we did our root of 273 in the calculator, we're going to find that A is equal to 16.52, which is matching up perfectly with what our estimate is. So this is the short lesson for the day. If you would like, I will post the link to that first hyperlink at the top of this page in our Microsoft team if you would like to go there and check it out. Otherwise, you can follow along with the lesson and then complete the textbook questions that I post for you. Other than that, have a great day.